This is Chapter 4, Problem 17. In this problem, we are given the acceleration for a cart along the x and y direction. The acceleration along the x is 4 meters per second squared, and the acceleration along the y is negative 2 meters per second squared. Now they give us that the initial velocity along the x direction is 8 meters per second, and the initial velocity along y is 12 meters per second. And they're asking us to find the velocity of the cart when it reaches its greatest y coordinate. Now recall that we need to integrate the acceleration in order to find the velocity vector. So the velocity vector would be equal to the integral of the acceleration along x and plus the integral of the acceleration along y. Now along x we are going to have something that looks like this, where it's going to be 8 plus 4t, and this is in the I hat direction. We integrate the acceleration along x, 4, that would go to 4t, but recall that the initial velocity along x has to be 8. So that means that at time 0 we have to have a velocity of 8, and that is the constant of the integration. Now we do the same thing along y, and we get that the velocity along y is 12 minus 2t. That's in the j hat direction. Once again, we integrate the minus 2, it goes to minus 2t, but the velocity along y at t is equal to 0 has to be equal to 12 meters per second, so that's where that comes, the constant of integration. The greatest y coordinate will come when the derivative of the position vector along y is equal to 0. The position vector along y is given as 12 minus 2t. That's the velocity. The derivative of the position vector is the velocity, and we need to set that equal to 0 to find our maximum or minimum along the y direction. Remember your calculus, guys. And we find that at t is equal to 6 seconds, we reach our greatest y component. Now the velocity at t is equal to 6 seconds is equal to 8 plus 4 times t, which is 6, and that's along the I hat direction. And we know that we should get a 0 for the y direction because this is the greatest y component of the position vector, and that's just 12 minus 12 j hat. And so we get that the velocity is equal to 32 I hat meters per second. So be careful on this problem. It's kind of deceptively simple. We're trying to find the velocity vector at the maximum y coordinate. At the maximum y coordinate, the velocity along y should be equal to 0. We confirmed that after taking the integral and substituting in the time. And then we substitute in the time to the x coordinate. We get 8 plus 4 multiplied by 6, or just 8 plus 24. And we get an answer of 32 meters per second along the I hat direction.